There is no denying the power of the walrus. It had been for many years known to hold valuable resources. Communities attempted to hunt it down, but it prevailed and continued to thrive in its environment. The walrus operator was here to stay. A PEP, or Python Enhancement Proposal, is a document detailing changes to Python. Back in 2018, a particular controversy arose after the publication of a new PEP, PEP 572, Assignment Expressions. It detailed how a new operator would allow assignment to take place within expressions. Officially, the operator is referred to as the Assignment Expressions or Named Expressions operator, but during the discussion of this PEP, the name Walrus operator was coined, with its resemblance to the eyes and tusks of a walrus. Those against the operator believed that it was not idiomatic, that it didn't follow the standard styles and patterns of the language, and did not adhere to the main principles of Python. These principles are usually accepted to be defined in the Zen of Python, authored by Tim Peters. You can find this by typing import this in Python. There are 19 guiding principles, but I want to focus on one specifically that was referenced in debates, that of there should be one, and preferably only one, obvious way to do it. Many believed that the walrus operator was breaking this principle, introducing an additional way to assign values to variables, in turn making the language less consistent. On the flip side, many argued that it makes certain code snippets more readable. There are also scenarios where it's been shown to improve efficiency. So, to better understand this discussion and explore how Python handles assignment expressions, let's take a look at the walrus operator in action. This is how the walrus operator is used to assign a value to a variable. It is the assignment expression operator, referring back to its official name, and as a result should always be used within an expression. This is why we need the parentheses around the statement. This is a deliberate choice to distinguish the assignment expression from a usual assignment, which would be done like so. Now, if we print both of these variables, we see that they're assigned to the corresponding string values as expected. So what's the difference? Well, if we write something like this instead, we can get a better example of the difference between the two. You can see if we run this code, the walrus operator correctly comes back with the string, whereas we get an error for the usual assignment operator. This is because the assignment operator is not allowed within an expression, whereas the walrus operator can be in expressions. It assigns a value to a variable and returns that value in the same step. With this in mind, let's look at some examples of where the walrus operator could be useful. We could, as an example, have a function which takes a number and raises it to the power of 5. Then we assign a variable to this list, each item in the list using this function. Usually we would do something like this, assigning the function call to a variable to avoid having to repeat its computation 3 times. We can see that we get the resulting list. However, to do this, we add an extra line of code. Instead, using the walrus operator, we could make the same improvement, but also keep it on one line. We keep the code efficient and concise, and still get the same value as expected. Here's another example. Say we have some data, and we have a list comprehension like so. Inside the list comprehension, we use the same function that I defined before in the previous example, that takes a number and multiplies it by 5. We cycle through all the data values, only keeping those that when multiplied by 5 are even. So this is the result that we get. It's a fairly straightforward example, but the main thing to focus on here is that we're calling this function twice, which is kind of inefficient. Imagine as well if this function was even more computationally intensive, say it took 10 minutes to run or something crazy like that. Minimizing the number of function calls we make is going to be really useful. Well, we can do that with the walrus operator, like so. By adding the assignment in the filter clause and then sharing this value later on in the list comprehension, we only need to call the function once, and we still get the same result as expected. This is a common case. Say we're matching some pattern using regex, For simplicity, say we have a string walrus and we want to check if it begins with a capital W. Before the inclusion of the walrus operator, you typically have to do something like this. Here we define match first, then check if it exists in the if statement. Instead, you could do this. Define in match within the condition itself, saving an extra line. Lastly, what about this? We're processing a file, splitting it into chunks to save on computation. The processing in this case is simply counting the number of words in each chunk. Normally, we would need to take the first chunk from the file, and then we could start processing. Instead, with the walrus function, we can simplify this by adding the chunk assignment to the while statement, once again improving the efficiency of our code. So, we've now seen a variety of examples of how the walrus operator can reduce the number of lines or improve performance in certain scenarios in Python. As we now know after long discussions, PEP 572 was accepted by the, at the time, BDFL, Guido van Rossum. He then announced in a letter that he was stepping down from the role and didn't want to fight so hard for a PEP and find that so many people despise his decisions. As a result, there was a reorganization of the hierarchy in Python, with the steering council model accepted as a structure for governance. All these discussions and debates pushed Guido van Rossum to leave his position. It all boiled down to change. Many in the community didn't want change, they wanted things to adhere to the principles of Zen of Python, authored by Tim Peters. The thing was, who co-authored PEP 572? Well, it was none other than Tim Peters himself. This has been a look at the walrus operator in Python. Thank you for watching.